Bulk density is a measure of how much space a certain weight of material will occupy. So that's including the air voids that might be between particles at their most expanded. This is important, for example, the max weight fits in the material hopper, or also for the maximum amount of weight of material that fits in the die, because of how much space that material's weight takes up. So here I've got a cylinder of a known volume, 100 milliliters, and I'm going to fill that cylinder through a mesh to break up any clumps, and then ensure that it is full. Okay, so now it's going to be weighed into a container, and we can see that there are 92.2 grams in 100 mils, so that gives a density of 0.92 grams per milliliter. Now I'm going to weigh how much this cylinder holds. That it held 65.2 grams to give a bulk density of 0.65 grams per milliliter. Once again, I'm going to fill it up and weigh how much powder is in here. Here you can see it's only 34 grams of material in that same 100 mils, so a bulk density of 0.34 grams per mil. I'll strike off. There we go. This material weighs 32.9 grams, a bulk density of 0.33 grams per milliliter. So very similar to ProSolve FSIMC C50, but it had quite a different flow. And now we're going to take a look at tap density, and at the same time we're going to do a rough approximation of the Hausner ratio, looking at volume of bulk material over tap material. This is not precisely how it's done in the pharmacopoeia, but will give us a rough idea of the flowability of these materials. So I'm going to fill this 250 milliliter cylinder up to the top, so we have our initial bulk measurement. On average, it's roughly 250. The weight's what really matters for the tap density measurement. And now we can see that the reading is approximately 226 milliliters. 250 milliliters, our starting volume, divided by 226, gives us a Hausner ratio of approximately 1.1, which is just on the borderline between good and excellent according to the pharmacopoeia. 192, that gives a Hausner ratio of approximately 1.3, which is passable in terms of flow. And for this material, it looks like the value is about 192 again, which is odd because the flow is actually much worse than the previous material with the same tap density volume reading. So the Hausner ratio is maybe not always the best. It represents some materials flow better than other materials.
In the next episode of JRS Tableting Studio, we take a holistic look at powder characteristics. By combining particle size, morphology, density, and flow data, we show how different material properties interact and why understanding them is essential for successful tablet formulation. JRS Tableting Studio. Stay tuned.